Hello, 7th graders. This is Mr. Shear, and today's topic is called Washington, a volcanic state. And you're looking at a picture here that if you lived 17 million years ago in Washington state, this might be your view. This is what our state looked like about 17 million years ago. Giant fissures of lava seeping up from the ground, forming much of the state that we know today. So I was hoping some of you might have made the connection. Why are we talking about Mount St. Helens eruption in 1980? If you looked at what we were talking about before Mount St. Helens, we were talking about the Great Missoula Flood of 15,000 years ago. We were talking about the Kennewick Man and the earliest people in Washington, 9,000 to 9,500 years ago. And then we jumped to 1980 and Mount St. Helens. So why did we start talking about Mount St. Helens when we had been talking about ancient, thousands of year old geological processes on our state? And the reason for that is you can't really understand the formation of Washington's landscape and regions without understanding some idea about how volcanoes and volcanic impacts have changed and created our modern state. So 17 million years ago, this was formed. And you're looking at a picture in eastern Washington, and much of eastern Washington looks like this. This is basalt, in a very simple way, dried lava tubes, and they're all throughout eastern Washington. Eastern Washington, and specifically the Columbia Plateau, is made up of giant basalt fields from lava. So these fields extend, you can see on the map here, down into Oregon and parts of Idaho. And these were not volcanic eruptions as much as they were formed by fissures, cracks in the earth where lava would seep up over thousands, sometimes millions of years, creating giant, archaeologically cool fields of basalt. And this was slow-moving lava, much like you'd see in Hawaii. Often it was way thicker than this and way thicker than anything we have in Hawaii today. Very thick, dense, slow-moving lava pouring up from cracks in the earth, forming this. And this is a picture of eastern Washington. These giant lava fields. And you can see the lines here, each one representing another crack in the earth and another layer of basalt and another layer of lava flow, forming much of that eastern Columbia Plateau. So I want to recap what we've talked about. 17 million years ago, volcanic fissures opened up and formed much of Washington state. 500,000 years ago, the Cascade Range was formed, including Mount Rainier. 15,000 years ago, during the Ice Age, the ice begins to melt, causing massive flooding, including the Great Missoula Flood. And 9,400 years ago, that's when humans first arrived, somewhere in that range, and began living in Washington state. So how does this happen? Well, the first thing I want to tell you is that we didn't have mountains here 17 million years ago. We had a giant underground, think of it as a lake, of lava. We had a huge amount of magma trapped in the earth. And we're living on the plates. These plates shift, but we don't have one solid landmass underneath us. Instead, we're living on plates. Plate tectonics is the prevalent theory of how the Earth's crust is connected. So these plates shift. So over time, that giant volcano underneath us, the underground field, has actually shifted, as the theory goes, to modern-day Yellowstone in Wyoming. So what has currently forming Yellowstone National Park, the geysers, the hot springs, the pools, all of that in Yellowstone, they believe first existed underneath what was now Washington and has migrated over time due to plate tectonic shifting. I want you to notice something else about these plates. Washington is right here where my cursor is. Just that little speck right there. You might notice there is a tiny, tiny plate called the Juan de Fuca plate, which is really just off the coast of Washington, Oregon, and part of Northern California. And that is a tiny little chunk of the Earth's crust that, compared to the North American plate or the Pacific plate, is a very small plate wedged between two giant plates. And what's happening is the Pacific plate is pushing the Juan de Fuca plate under the North American plate. So the Juan de Fuca plate is getting pushed underneath the North American plate. And that's causing lava to come up and create mountains, the Cascades. Things like Mount Rainier. So if we've got this plate, this tiny little plate that's creating and forming mountains, will we have another eruption? Well, on this image, what you're seeing is the Juan de Fuca plate going up into British Columbia. It extends up in about southern BC. It's got Washington, Oregon, and Northern California here. And this creates the Cascade Range of about 20 significant volcanoes running up and down the west coast of North America. So some of these mountains, of course, you'll recognize as Mount Baker, Mount Rainier, Mount St. Helens, and Glacier Peak in Washington near Arlington, Mount Adams. But you might also recognize some of these other mountains like Mount Hood in Oregon or Mount Shasta in Northern California. And then, of course, you've got Silver Throne and Mount Cayley up in British Columbia. And they do erupt, and they will erupt again. This chart tells you that most of these mountains have erupted at some point in the last 4,000 years. If you look at the chart, you can see that the most active by far is our buddy Mount St. Helens, which is quickly followed by Mount Shasta in California and Glacier Peak near Arlington, Washington, pretty close to us. If you look, Mount Rainier has been fairly active in the last 200 years. It has had an eruption. Mount Baker's had an eruption in the last 200 years. So when was the last eruption? Well, Mount Baker last erupted in 1880. Mount Rainier last erupted in 1894. It's not that long ago, geologically speaking. Glacier Peak erupted in 1700. Mount Adams, long time ago. Lawson Peak was another big eruption. It erupted off and on for about 3 years in Northern California. There's a Lawson Peak National Park. It's a great family road trip if you ever get the chance. It formed a very interesting landscape and caldera there. And then you might be interested to know that Mount St. Helens has erupted since 1980 and continues to have small eruptions. It last erupted in 2008. So mountains continue to erupt. What made Mount St. Helens so significant was the massive, 500 times greater than the atomic bomb, massive force of the 1980 Mount St. Helens eruption. So will the Cascades erupt again? The answer is, of course, yes. One of these mountains will erupt again. Will it happen in my lifetime or your lifetime or in the next 50 years? Who can say? I will say that geologists study these things. They keep an eye on these things. And of course, we learned from the Mount St. Helens 1980 eruption, and we're probably going to be safer this time. All right, guys. So that's a little bit about why we're talking about Mount St. Helens. It's a little bit about the geology of Washington State and how volcanoes have had and will continue to have an impact here on the formation of our state. Have a great afternoon, and thanks for watching.